This video is brought to you by the Environmental Protection Agency. The use of any trade names or commercial products does not constitute an endorsement on the part of the Environmental Protection Agency. This video is intended for small systems and will present information on small system considerations when selecting an arsenic compliance strategy. The arsenic rule established a new maximum contaminant level, or MCL, for arsenic of 10 micrograms per liter that becomes effective January 23, 2006. The arsenic rule identified a number of treatment processes as best available technologies for arsenic removal, such as activated alumina and ion exchange. Because of the many technologies currently available for arsenic treatment, systems are faced with a number of challenges when identifying and selecting the appropriate compliance strategy for their particular situation. Some states have been very proactive in identifying and conducting outreach to systems that will be affected by the new arsenic MCL.
We've probably conducted, I would say, over 75 workshops, seminars, training sessions. We've done them in consultation with here in Arizona, our Corporation Commission, which is the Public Utilities Oversight Agency, so that we could not only talk about the technologies that were needed, but also how to adjust rates to support the debt service necessary for installation of those technologies.
The compliance strategy selection process presented in this video is based on information contained in the Arsenic Treatment Technology Evaluation Handbook for small systems. This handbook is available by going to the EPA website shown on the screen. The first consideration is to identify non-treatment options, such as abandoning the source that is high in arsenic, blending sources, rehabilitating the well high in arsenic to access a better quality aquifer, developing a new source, or connection to a nearby system. If these non-treatment options are not possible due to limitations in water quality, water rights, or a nearby system not being able to service the system, then you must now start investigating treatment options. The first step is to characterize your source water to determine if co-occurring contaminants present treatment limitations. Some of the arsenic treatment technologies currently available, such as adsorptive media processes and ion exchange, are sensitive to competing contaminants present in the source water. The decision trees in the handbook provide more detailed information on the significance of source water characteristics. The treatment selection process can be overwhelming due to the vast amount of information available. Some states, such as Arizona, have provided educational opportunities to systems.
We hosted a vendor fair here in the state, reserved a conference room and invited all the water systems that have arsenic problems that were contained in our listing from our original analysis. And all of the vendors, we sent out notices to vendors across the country and provided them with a free booth and a captive audience of water systems so that they could tout their wares to the water systems, and also so that the water systems could get side-by-side comparisons instead of people visiting their facilities at different times. And then added in a couple booths. We had our technical engineering staff down there to provide some unbiased advice and analysis of information that was coming from the vendor booths, as long as our Corporation Commission to talk about rate structures and considerations in terms of getting rate adjustments and that sort of thing. And so we've really done a lot.
As you investigate new treatment processes, the following are some considerations that will impact treatment selection. Blending of raw and treated water to reduce treatment plant size. Size and land requirements for treatment facility. Quantity and quality of residuals produced. Residuals handling and disposal. State review process and acceptance of emerging technologies. If the arsenic levels in your source water are low, perhaps between 10 and 25 micrograms per liter, you may be able to treat a portion of the raw water and blend treated water with raw water. This mode of operation will reduce the size of required treatment processes and result in cost savings to the water system. The size of your treatment facility will depend in part on the type of treatment selected, the flow rate, and blending operations if practiced. Depending on your system configuration, and if your system has multiple entry points, you may want to evaluate the costs of multiple treatment plants versus the cost of one centralized treatment plant and piping multiple entry points. All treatment processes create a residual. Examples of residuals are spent filter backwash that is generated when media is backwashed, or regenerant streams when ion exchange resins are regenerated. The quantity and quality of residuals depends on the arsenic concentration in the source water, the treatment process, and the frequency at which residuals are generated. For instance, the ion exchange resins in these vessels are regenerated every 12 to 24 hours. It is important that you characterize your waste as to whether or not it is hazardous based on the toxicity, characteristics, leaching potential, or TCLP test. The volume and characteristics of your residuals will determine what handling and disposal methods are available. For instance, the anion exchange process previously shown has a simple and effective residual handling program. All residual streams generated during regeneration are sent to this temporary holding tank and then pass through these containers filled with granular ferric hydroxide media. The media in these containers absorb the arsenic in the waste stream, and these containers are periodically removed and taken off-site for disposal. The media has been characterized, and it passes the TCLP test, which indicates the material is not hazardous. The residual stream from these containers is sent to another holding tank. Once this holding tank is full, a pumper truck comes, pumps the liquid out, and takes the liquid off-site for disposal. Again, this residual stream has passed the TCLP test. It is very important that you contact the state to obtain their input on acceptable technologies. The state may also require specific pilot testing and monitoring prior to issuing final approval of your proposed treatment system. Some systems have taken an innovative approach to the treatment selection process by requesting bids from vendors and other companies to provide treatment on a contract basis.
We have bid these in a way that we have not specified the technology on the bids, and we have opened up the bids to a number of different technologies. We are basically doing a turnkey bid where they're doing all of the design work, all the testing required, all the permitting, all the startup operations, training of personnel. We put the entire burden on the contractor, engineers, vendors to more or less get that project into a position of being to operate consistently under contract for 5 years.
Once you have identified the best treatment option or options, you should develop preliminary costs. Capital costs consist primarily of equipment purchase costs, land purchase, construction, and installation costs. Operation and maintenance costs consist primarily of electrical costs, media or resin replacement, chemical costs, labor, and other system costs required to keep the treatment plant operational. These costs will probably be used to determine funding strategies and rate setting.
Well, as far as evaluating the costs, the overall costs, we have to look at the capital cost and the rate impacts from that, but also the O&M costs, the life of the facility. There are certain categories of costs that are not recoverable by us as a utility without having a rate case, a full rate case. And as part of our approval process from the Arizona Corporation Commission, we had to narrowly define costs associated with arsenic treatment that we could recover without having a full rate case. We targeted those costs that were unique to arsenic treatment, and those generally are the media replacement costs, media servicing costs, and the waste disposal associated with arsenic treatment. So those are the only categories of O&M costs that we're allowed recovery on outside of a full rate case.
Once you have constructed and commenced operation of your system, you should have an approved monitoring schedule based on state input, that dictates the contaminants to be monitored and the frequency of the required monitoring. Typically, monitoring is conducted quite frequently during initial operation, and then reduced if results are acceptable.
But for the most part, what we do is the first 3 weeks of operation, we sample 3 times weekly, both with our portable test kits and also sending those samples to the lab. That goes on for 3 weeks. For the following 3 weeks, we sample weekly, both with a portable test kit and sending it to the lab. The next 3 months, we send monthly samples to the lab and also using our portable test kits. Those first, essentially 4.5 months, are all considered process control monitoring, not compliance monitoring. At the end of that initial process control monitoring, at the end of that process, we establish our first compliance monitoring, which is then done on a quarterly basis from the plant.
You will want to consult the state on the possibility of using test kits as an alternative to certified laboratories performing all analysis. For more information on arsenic treatment technologies and other arsenic rule information, you can visit the EPA website on the screen.